Okay. In this, we are given integral of cos of 2 tan inverse under root 1 minus x by 1 plus x. Okay. So cos of something and dx. Okay. Obviously, we need to do some kind of substitution. So, and obviously x is less than 1. Okay. 1 minus x by 1 plus x. Right. 1 minus x by 1 plus x. So now tell me if this has to be positive. First of all, this is under a square root. This has to be positive. Right? If this has to be positive, then x should lie between what and what? 1 minus x and 1 plus x. Okay. So, agreed, ba? 1 minus x and 1 plus x. When is this positive? When is this positive? So, when is this positive?
When x is less than 1.
When x is this one. This tell about this part. When x is greater than minus 1, right?
X is greater than 1.
So there is some minus 1 and let's say there is plus 1. When x is greater than minus 1, this is positive, right? Here it is negative. What about this one? When is this positive? When is this positive? 1 minus x. When is it positive? When x is less than 1, right? Agreed, ma?
Yes, sir.
1 minus x.
Yes.
So what does that mean? This expression, this is positive between minus 1 and 1. Agreed? This expression is x is always lying between x is always lying between minus 1 and 1. Okay? This much we are clear. So that's why we can take a substitution of cos theta now. Agreed? Cos theta or sin theta. Here we'll choose cos theta because 1 minus cos theta by 1 plus cos theta, we can do something. Agreed? So why we are doing cos theta substitution? First of all, cos theta substitution should be valid. It is valid because x anyway lies between minus 1 and 1. And now we are doing this cos theta substitution. Then what will become of this? We know 1 minus cos theta by 1 plus cos theta. 1 minus cos theta we know, which is 2 sin square theta by 2, right? This becomes what? 2 sin square theta by 2 by 2 cos square theta by 2. Agreed? Which becomes tan square theta by 2. Square root of that will become tan theta by 2. Okay, so tan inverse of tan theta by 2, which is nothing but theta by 2. We are getting this as this entire expression as cos times 2 theta by 2, which is nothing but cos theta. Agreed? This first phase. Now we have a dx. What is dx? When x is cos theta, dx is obviously minus sin theta. So we have simplified this integral to this one. Okay. Now what he's doing? He's doing one more substitution. Cos theta is t minus sin theta d theta is dt. So that's why t squared by 2 he is doing this. Or otherwise also we can write it like minus half of sin 2 theta d theta. Right? Agreed? We can write it like this also, right?
Yes.
Then what will become of this integral of sin theta? Sin 2 theta, what will happen to this?
Or we can write it as sin theta cos 2 sin theta cos theta.
No, just we can, direct integral of sin x, right? Sin ax. What exactly is that? Integral of sin ax.
Cos 2x by 2.
Cos 2 theta by 2, there is a minus of. Cos 2 theta or minus cos theta? It should be minus cos theta.
Yeah, minus cos 2.
So this becomes plus. So we are getting cos 2 theta by 4 kind of thing, right? But we are getting this result. So is this also correct? Yes, this is also correct because cos 2 theta we can write it as 2 cos square theta minus 1 by 4, and that 2 cos square theta minus 1 by 4, right? This also becomes cos square 2 theta, cos square theta by 2 minus some minus 1 by 2 or minus 1 by 4 plus some constant. So that is getting adjusted in this constant. Okay, whether you mention it like this or you mention it like this, you still get the same result. Only thing that differs is the constant. Here the constant might be different, here the constant might be different. Okay, ma? Understood this, no? So here, why we are
Yes.
choosing x as cos theta? First of all, one thing is that will simplify this one, this expression. At the same time, x cos theta is valid. It should be valid. What does that mean? X should lie between. We should be convinced that x lies between -1 and 1. Then only we can take cos theta. Otherwise, we are restricting this one. If x can be anything, and we are putting cos theta, that means we are restricting the value of x, which should not happen. Okay, ma?
Okay, sir.